I'm going to very briefly introduce the only two new speakers, or rather, they may have to introduce themselves. But I first wanted to just say this and remind you. So we have been talking about robotics. This panel debate will be particularly about the application space and whether we are at an inflection point for applied robotics. And we will explore what that might mean in the now, in the near horizon, and in the future. And I'm particularly curious about what future means to this panel, because typically, as you know, future means somewhere far away. When I was in school, we were talking about 2020, or we were talking about 2030. And you know, some of those years are actually still pretty far away. But I wonder, and that's going to be one of the questions we'll be exploring, is future really so far away for robotics? Or you know, what are the time frames we're talking about? But let me get directly to the two new people on stage. And they are actually both at the end. So let me start first with Grant Allen, Managing Director of ABB Technology Ventures. Did I say that right? Yeah, I did.
You did.
I did. And lastly, Tom Ryden, Executive Director of Mass Robotics. And we'll hear a little bit more about what mass robotics is. But I'm very thrilled to note that in this very room, actually downstairs in this very building, about 3 years ago, we kicked off the first startup exchange event. It was called Robotics Going Mainstream with a question mark. And we featured Vecna, in fact, who were on stage here earlier. And they took the initiative to this event. That was before mass robotics even existed. And we have had, I think, some, we were a precursor to helping them get some of that environment up and running. We'll talk more about mass robotics and what it means for Massachusetts and the world. The rest of the speakers have, of course, been introduced. I'm going to just really quickly point to the fact that I am blocking your view. But here they all are. Without further ado, I want to kick it off. This is, I hope you appreciate, a tricky task. We have 6 speakers. So we're going to have to go a little fast. I will quickly retire my poor questions, and we will move to a more interesting stage, which is me throwing this little mic around. Most of you who have been here know this. If you get one of these, try to catch it before it hurts you. So there's going to be another experiment of mimetic, robotics. Anyway, let's start at the end here with Alex. I want to hear, what is a robot?
Robot is a tool that we are using in high-volume production for repeating tasks, very accurate, very fast.
Yep.
And that is something that is there since, I would say, 15, 20 years.
Okay.
And hasn't changed that much.
Makes sense. Sangba, what's a robot?
Sense, think, act, but the act cannot be just voice or display. Act has to be physical. Yeah.
Act is physical.
Physical action.
We don't have to go all the way down around, but if you have a view on what a robot is that is distinctly different from these, what is a robot to you, Mao?
I would say a robot also enables us to explore areas that we couldn't conventionally do with humans.
Okay. Sampati?
Well, to me, it is something that gives you superpowers that you can't do by yourself.
Great. Grant?
Within the ABB context, I think we're looking at the periphery around what we've been doing since 1974, which is taking that high-precision fixed arm that's doing the same thing a million times and saying that's going to have an extra dimension of intelligence or mobility or something else to give it effectively industrial superpowers.
Tom?
So we run a shared workspace for robotics companies. So one of the challenges is how do you pick what is a robotic company? And we look for a couple of key things. One is onboard intelligence and the ability to react to the sensors and the data that you're gathering. And also mobility, some form of mobility. And this doesn't mean that the robot will actually move through the environment. It could be just an arm that's mounted to a table, but there is motors and actuators and so forth in the system.
So why do you think that we have chosen to bring both, I guess, robots and sensors into this discussion? We're not going to go along the line, but does anybody want to comment on the importance of sensors to the current state? I was maybe thinking of challenging you, Sangba, on why sensors now is so embedded with the discussion in robotics.
It's not super clear where exactly the challenge is the pinpointing, but I don't think we are lacking of some sort of sensing technology. we're lacking of like how to interpret those sensors. For example, like we typically have a 6x4 sensor at the end of the robotic hand. Those are fine as long as you interact with that point. But when you hit something like some other place, we have to cover with the sensors, which is we can do. There's a robust industry might be able to solve it. The problem is like, how do we interpret this like millions of sensors at the same time? That's what animals do all the time. You probably know that your eyes have this amazing resolution in a small area, and then there's low resolution. But this amount of data is just amazing. But there's the intermediate processor actually that give you very abstract data to your brain, so you don't need to deal with this as so many data sets. So it's more like a lack, not like a lack of sensor. It's more of a how do we quickly interpret the data in a way that we can maximally utilize for our purpose, depending on what you were doing.
So let me ask you about the diagnosis, all of you, of where we are with robotics. Are you, I mean, where are we with robotics right now? Is the diagnosis that this is a good situation? Alex, from what you said, it seems to me that in industry, the way you think about it, robotics is in a good place even currently, and you're dealing with adapting, and you're excited about the technology. So would you say robotics is in a good place currently in manufacturing today?
Yes, it's in a good place, and even with existing and current technologies, it has a steady growth, but this will be enhanced with now the sensory feedback and making that robot reacting like humans,
Yep.
or other birds or cheetahs or.
Would you agree with that, Grant? That in your environment, with with your organization, that robotics is in a sort of a healthy state of development. I mean, you've been doing
ABB
this
is the #2 robotics player in
for
the
a
world,
long time,
and we are having one of our best years ever. So in our core industrial robotics business, that's doing fantastically well. I think the question for me as a venture investor is what's that layer on top of that? And I think from my perspective as a venture investor in the Valley, we see a bit of a Cambrian explosion of startups going after the other tasks that involve all sorts of complex sensing, manipulation. And initially going after the holy grail of generalized intelligence, a lot of them figured out that we can't just take a lesser robot and make it so smart and so capable with just software. And so we're seeing a bit of retrenching and going after vertical applications. But the number of pitches I've gotten in the last 6 to 12 months has been order of magnitude different than, say, 3 years ago. So there's a lot of companies chasing after this and a lot of money going after the problems as well.
Okay. Tom, maybe you can give us a sense of how many companies are in mass robotics, what are they currently doing, what is the here and now, without going into one of the more futuristic applications that they have, the clients they have, whatever they're exploring in the here and now. Among those, you have 18 companies?
We have 18 in our shared workspace. We work with about 45 startups, 50 startups, I think, in the greater Boston area. So I would agree with Grant. Really the startup scene is exploding in robotics. And I think there's a couple of reasons. One is the barriers to entry have dropped. There's a lot of commonality now, that whether it's ROS, robotic operating system, or other components that are much more readily available. So it's easier for you to get into and build a robot. And there's also a lot of support within the community. And so we're seeing a lot of trends to see even more startups. I'd say the #1 area that they're focused on is automation, is factory automation. We see the most startups in there, and you had a number here talk about it. And then there's Soft and VO, and the list goes on and on about these companies that are really looking to improve the way we use this automation within factories. But beyond that, we see startups in everything from logistics, which is a very popular area here, driven a lot by Amazon Robotics and their efforts purchasing Kiva. We see it in self-driving vehicles. We see, Boston supports that, so there's a number of companies that have moved in and doing that work. And then drones and other areas, the list goes on and on.
Perfect. So we'll soon get to animals, and we will get to oceans. But before we get to those very exciting and, I guess, novel use cases, let's talk more about some of the more traditional use cases. What are some of the other use cases that you see around for near-term robotics? And this is open question, and anybody can pick it up. So we've talked about logistics throughout the day. We've mentioned a lot of different use cases. If you were to even just think about what are the top 3 existing use cases for industrial applications of robotics and on the horizon, so automotive would be maybe in the top 3?
What I'm doing in advanced manufacturing and autonomous manufacturing. My colleagues are doing with the product the autonomous driving. Also, the vehicle turns into a robot.
Yep. Any other areas? So, advanced
Tom
manufacturing?
mentioned, two companies, both Robotics and Soft Robotics. I'm an investor in one of those companies. And again, when I mentioned that there was a slew of companies going after generalized intelligence, I can't even count the number of pitches that I got, which was low-cost robot, we're going to make it do amazing things with software. And it's going to be $10,000, and that's great. But the fact is, these collaborative applications are pretty tough, and a lot of the collaborative robots that we see out there are not truly collaborative.
Yeah.
They're safe when they're operating at slow speeds. But when you get to production environment, like that fantastic video you showed of these high-precision movements inside the BMW factory, those are tough challenges, and you need to deal with fundamental issues around safety and human interaction. So to go to VIO, I mean, they're doing a really innovative speed and separation monitoring platform using time-of-flight sensors. It's a really cool application. Soft is going after a totally different problem, which is picking up very soft things with an agile adaptive gripper. So it's a soft elastomeric gripper. It's a spin-out from Harvard that uses basically silicon rubber, stiffens it, and it can pick up a lot of different things that our traditional hard grippers cannot. So again, it may not be intelligence in the sense that we're applying AI into the software, but if you define it as intelligence as how we interact with the world, this robot can now interact with a slew of things it could not before. So I would say we're going up the food chain in terms of intelligence of the robot.
So Grant, in our pre-discussion, you also did point out that in the past you got a lot of pitches from robot companies making robots. We have an individual robot and it's great and it's going to cost X and we're going to spread it everywhere. And you said something about your pitch now is you're more excited about there obviously has to be a physical formation, but it is the software and the overlay around
hardware
it.
advancements,
right?
And we're just seeing such rapidity of technological innovation from the automobile and the drone side.
Right.
I'm going to stipulate to those sensors and a lot of that intelligence seeping over into the industrial side. So you take these horizontal layers that we're trying to build hardware with software on top of it. You're going into vertical applications, whether it's an agriculture picking application, going after lettuce farming in a containerized urban farming situation, or something that is going after a very discrete problem in a manufacturing setting. And the best companies I'm seeing are taking that and driving deep. They're looking at a solution, a very specific customer pain point, solving it with a robust solution that we can deploy in the field and actually make money with.
Okay. All right, so now let's move to the kind of the near-term horizon, and let's look at some of those things. We have two industrial representatives here. What industries themselves are sort of ripe for disruption? And this is maybe the first to sort of bring in the oceans and the animals. The oceans full of industries exploring the ocean. Sampriti, maybe you can speak to some of the industries that you guys are thinking of disrupting, helping.
I mean, the ocean is like $1 trillion economy right in your backyard, from like future of like food to new sources of energy, medical resources, and even if you think of like cargo ship fleets, right? Like 94% of the stuff that you use are like shipped from somewhere, and over 50% of the shipping costs are due to people on the ship. So you can imagine that autonomy in cargo ships would be one of the future things you're looking at. You're looking at, underwater exploration for various, as we talked about, different applications there. One of the big thing, especially in defense and security, is like the next generation threats, because it's not going to be normal mine countermeasure. It's going to be biological threats, chemical weapons, and how do we look at new sense of like how do we secure our ports? Like everybody is worried about in airports how you are like looked at, but seaports are very, very complicated areas for monitoring. So a lot of innovation there.
So cargo and aquaculture. What about you, Maha? You mentioned some other applications of monitoring. What industries are interested in? Is it the security governments that are interested in ocean monitoring? What are the main industries involved with that?
Yeah, and then also I think any industry that has assets offshore, so whether that's oil and gas, deep sea mining, offshore wind that is blowing up, and aquaculture you mentioned already, these assets are expensive and need to be monitored and prevent, do safety maintenance and that kind of thing. And so having a cheap and reliable way to monitor those is really important. And then also we're seeing more extreme weather events. And to help predict when those events might happen or how those hurricanes might move, we need more data. We need better data. And those are extremely harsh conditions to send a pilot in, even though we do. And if we can send something that's low cost and cheap and get much more data, we can help evacuate many more people.
But on the other hand, hardware innovation, which I guess it still is entrenched. The robotics innovation environment still has some aspects of hardware. And what are you guys hearing when you're out there talking to people like Grant? I mean, it's, from what I understand, a difficult environment so the applications are really exciting, but the timelines and the complexities are daunting. What are you feeling around that? Do you feel that is being overcome now, that there are lots of industries and also venture capitalists who are more willing to entertain these very big scope sort of industry changing discussions, or are you finding that the rhetoric is still ahead of, I don't know, the purse?
I think it's definitely shifting. I think in the past, places like the Department of Defense, at least in the United States, would really fund very large-scale million-dollar projects. And they're seeing this revolution happening at a much lower cost and scale. And so they're starting to see that there's a need to start investing in innovations that could ensure our security on a national scale. And then I think also industries are seeing this. Very large industries that work in these spaces are looking to innovate on a much smaller scale, and they're looking for strategic partnerships with both startups and universities to really build this research up to a point where it could then enter that corporation or the industry.
Yeah, I just like to add something. I mean, I think it's a chicken and egg problem. I mean, there's investors have been very used to funding software companies, but what you really need to realize is the scale of the capital that's needed for a software. If you really want to have a ROI, like return on your investment, you actually have to spend 5 times more on the hardware, and the ROI will be much more higher. Most of the hardware we are doing, it's solvable. But the reason you're slowing down, you're trying to optimize with a small amount of capital that, we have to go cheaper ways of doing this and improving our prototype. But if you're given the capital, you can speed up, because most of the problems we are dealing with is really not unsolved hardware problems. It's just, can we have the luxury of really doing this fast by getting the best.
Sure, but we do agree that with even with a new type of robotics startup, you get further in software innovation with 200 to 500,000 than you get in robotics innovation. Maybe Sangba, maybe you can address the question of research into robotics. What are you seeing? Let's say over the last 5 years, what's happening in terms of the interactions your lab has with the environment? So clearly, everyone's fascinated by your work, and that's not the problem. What are you seeing in terms of more substantive engagements with, I guess, the use cases for this, and where are you exploring? You were giving us some brief indications, but which industries are interested in this? You said public safety and disasters. Is that your direction right now?
So, just speaking of my perspective, I've been only reaching out like a niche cases like power plant security, power plant inspection, and nuclear material management, or potentially disaster response, all these cases where we don't want to use a human. We can use human sometimes. Like in nuclear industry, the regulation is so severe in a way that they can joke about it, but even some radiation level lower than taking airplane, they have to record, because they're living there, they're working there every day, so they're regulating severely more and more and more, and to really help control their health, help their health, as well to manipulate public appearance. The people, everybody's scared of this disaster response, the nuclear disaster. So there are a lot of areas we don't really want even human to even get near. Period. So I've been working on that area. In terms of this general academic industry relationship, I think there's a lot of it's kind of like fighting between you have to maximally advertise your work, and that always involves the hypes and the bubbles, and then they're kind of chasing rabbit, like I try to show this way, and then misunderstanding. And I think this is not. I'm not saying it's a bad thing, but I think we probably need more frequent and richer interaction rather than just like a superficial, because you can't really get through this spiral of hype and then figuring out where the bubbles are. I think we need more frequent interaction so that the academic become more realistic. They can look at the realistic problems and can get to the solve, and the industry actually understand what's challenges, what are the limitations of the existing technology as well.
So speaking about hype, but also I felt like many of you spoke of this in very positive terms. So AI is obviously something everybody talks about these days, and several of you mentioned it, or machine learning at least you mentioned in your slides and in your discussions, in a positive light, I think, and ABB's speaker earlier spoke about that and how it's being integrated. Does anyone want to address the potential issue I might see there is, surely a lot of the people working in AI are software people, or maybe they're statisticians or they're data scientists. But now you're dealing with applying it to a physical context. So there's the complexity of that. How is this all working out? Because if Wired were to have it right,
question every panel, it's kind of like, oh,
AI
what's the Elon Musk existential threat? And I think it's hogwash.
So
I'm much more concerned personally with the
can
millions
walk
of
out of
lines
this
of
room
code
safely.
written into a car
Yes.
that's hurtling down the road in a highly unstructured environment at 75 miles an hour, and no ability to audit that code as it's making decisions about merging into my lane and potentially harming me, than I am about layers of code going on top of an innately safe, safety-controlled industrial arm that could whack me. These people are assuming risk. They're going inside into a factory with no cage. There's an assumed risk. There's going to be a lot of regulations that are layered on top of that, but I'm much less concerned about that than a lot of the other autonomous things we're going to see out in life, including the AI applied to financial services managing my money. I'm much more worried about that kind of stuff. So are robots going to become intelligent and come after us? It's science fiction.
So where are we actually? Let me get a temperature from the panel, and that the quote from Hans Moravec from the 90s said that it was immensely complex to even get to a 1-year-old. I've heard a lot of things in the media about 5-year-old. There's been a lot of discussions about whether robots now are 5 years old. What is the age of the robot that you guys are working with? Let me just get this out. How old is your robot? Maturity level. And then we can talk about age.
That toy with the different holes shapes, and it can find the pieces going in.
Yes, I played with that.
So this is 3-year-old, 2-year-old, 3-year-old.
Okay. All right. Good. All right. So your robot is 3 years old maturity, and yours?
I would explain different way. Like I wouldn't answer that question. By the way, I don't think we can even evaluate how much we know about our brain. You can talk to brain scientists. You can talk to anybody. You can talk to like a neuroscientist. You have absolutely no idea how you use your tongue. I ask that question to every lunch meeting. You're eating by chomping this two-piece rigid body with the from 5 to 6 axis machine and chomping down. Have absolutely no guard. You have a one tongue. You push the foot inside. Oh, come back! It's crushed. Come back. And then you somehow with one tongue can find, oh, this is small enough. Throw it back. And then you find this small piece of paper. Why is it here? Piece of paper is pretty soft, right? But know how to push that in front of the tongue, and then your lips are coming out while you are talking to your friend, and make fun of your boss. We have zero idea how your muscles are doing this amazing behaviors. The reason why I talk about tongue is the tongue is actually one of the most highly dense area where the sensors are so dense, and then muscles are kind of complex integrated. You can have the same argument with your finger. You can have the same argument with your eyes. You have absolutely no idea what you're looking at. Did you guys know that you're actually looking at 80 milliseconds past all the time? You cannot see the present because there's a heavy processing going on. We know about probably very peripheral part of the intelligence of a human body. I cannot even judge how smart my son is. I don't think that's a very arrogant way of seeing it. One thing we can compare with the animal to the machine is we are at the reflex level, because we don't know what's going on beyond the reflex level. So what do I mean by reflex? Have you guys saw this big Boston Dynamics big dog, people kicking and then like jumping? You know this like a massive like internet. Oh my God, that's so cruel. And then stop a second, think about this is thinking. Is that a thinking or a reflex? You saw like a 5-year-old girl is very pretty, and then oh my God, it's pretty. Do you think that's a thinking or a reflex? I saw an apple. Oh, I want to eat. That's not a thinking. That's a reflex. I saw a monkey. Oh, that's a monkey. That's not a thinking. That's a reflex. I grabbed something cold and ooh, it's cold. That's a reflex. Thinking is beyond all this reflex level. I saw a pretty product. I want to. Oh, it's pretty. It's just some attraction. But you have to think about it. Like, do I have enough money? Should I buy something else? Whenever go beyond the reflexible, you can quantify it. What I mean by quantify, you cannot use numbers.
Don't you love this about MIT professors? You ask them a question, they tear it apart. So luckily for me, I'm in the privileged position that I can cut the question if no one wants to answer it. We can come back to it, but somebody has an answer. And then I have the privilege of sending this ball around. So if anybody wants to have their questions, answers, or crushed, it's all here. But somebody.
So, you know, I do robots both for work, hobby. I'm very fortunate in that. And during my PhD, I got distracted by this whole thing because I really wanted this whole concept of cyber cloning, which is, before I die, I want to just digitize my entire self, and that's what I've been working on, like when I get time.
So your hobby project is cyber cloning.
Yeah.
Okay.
And it's funny. I do agree with this reflex thing, and I've been trying to understand a lot of this. We turn out to be way more deterministic than we think we are. And a lot of it is not, the answer always to prediction is not just using CNNs. And, you know, people have different definition of AI. In a particular book level, there's AI, there is Bayesian, there is statistical regression models. We kind of look at it differently, right? So the answer to predicting everything is just not convoluted, you know, CNNs. So I actually think that it's not far away in the future that you will have digital cyber clones of your own self in the cloud, and which has your choices. And you can understand it because you're having Alexa to Siri predict and know what books you like, what you read. Put a bunch of your motion sensors on your body. Your avatar can imitate how you walk in like a video game like Second Life. I actually uploaded a bunch of my x-rays from my teeth. And then you can also have a cavity model of cavity, like root cavity, how it propagates. So I just see a future where, you know, the intelligence, we have to understand how we are comparing intelligence between robots and humans, but it's not that far off.
I guess my starting point was, you know, you guys were talking about animals, and then a lot of people are talking about how intelligent are robots, and it's very natural to use the metaphor of a child to compare robotics. But of course, it's not as simple. And as Professor Kim earlier mentioned, you know, you are trying to extend human capabilities by making the limitation of limbs flexibility, you know, not count. And you're saying avatars obviously have. They don't get as tired, as long as you have the, you know, the air provided and the electricity for the computer.
Yeah, and I would add one thing here that people always say is very far off, but I always think that how long did it take us from get to know light bulbs to mapping like every part of the world, like, you know, with a satellite to very high precision? Right. 200 years, very small in the ratio of human civilization. So I would say, you know, you're not too far.
I do think one important thing to note, though, when we always go down this path of are robots smarter than humans or vice versa, when are they going to cross, is that there's an assumption that there is, you know, a humanoid robot or some sort of anthropomorphic nature in the robot. But we see things that are so much better than humans already for a very specific task. Right. And I go back to that dirty, dull, dangerous objective of a lot of these robots. And the repeatability and accuracy of an arm is light years beyond what a person could do. And try doing the task where you close your eyes and you have to get your hand back to the same position. Right. You won't be able to do that. So to do the same thing a million times, I mean, we're so far beyond what a person would be able to do. So I think it's important to focus on the specific application.
Tom, do you have a quick feedback on any of this discussion? And then I'm going to start throwing the ball.
To Grant's point, in a structured environment, the robots are much better. But in an unstructured environment, we have so much further to go. And Rod Brooks gives a great example of, to your age point, if you take, and I think he used, I'll probably get this wrong, but if you put white sugar and cotton and a crumpled up piece of paper, all roughly the same size on a table, robots have an incredibly hard time differentiating between those and understanding which one they can pick up with a gripper, or they'd go right through the sugar, but they can pick up the paper. A 2-year-old can look at that and understand that. And so we have a long way to go in these unstructured environments for us to be anywhere close to what a human can do.
Right, but that may also not be desired in any robots anytime soon. So that's a good point. So who wants to go first? Let me see if there are any questions. I know the audience is full of robotics people.
All right, is this working? Yep. Okay. I'm Jim Gerard. I'm from Worcester Polytechnic Institute, and my interest is in the driverless and autonomous vehicles, land-based. And it seems like the hardware is developed. That's nailed down. It's in my Mazda right now. The problem is on the software side, and this whole aspect of creating an experience database, decision modeling database, and all of the folks that are in the business seem to be doing it on their own, independently, trying to invent the wheel. It's mechanisms that we can provide that allow more open source, more collaborative, more cross-licensing at a granular level, atomic level, that would allow these different companies to share the knowledge base and a much better product.
I don't know who wants to pick that up, but there seems to be more of a software issue than a hardware issue. The question or the comment is go ahead.
Yeah, I think it's about fleet training. So it's about there has to be a platform where basically whenever a car is learning something, it has to be accommodated at a common place. And I think this is something that different companies or corporations have to agree. This is more like, I guess, a business decision, but that would be the best idea, that where we call it fleet training, every car experiencing and learning, and that could be shared by other cars, and then you can upload behaviors on all the other cars, because that would really help even in different car companies. So that's what for example, Uber uses in their own fleet, but that has to be done across platforms.
Is anybody else on the panel involved in any kind of sort of open sourcing of experiences or data on the software level, or does any of the companies, Grant, you invested in, engage in any kind of sharing of data in that fashion?
Well, for our startups, the prevailing narrative of a lot of these companies is that it's such a enormously valuable problem to solve that owning that data is still worth it. So that's why you're seeing a lot of these one-off. Google's trying to own that. Other companies are trying to own that. With our companies, none are going after these hugely unstructured, open, outdoor autonomous vehicle problems. So that's less of an issue.
Yeah.
So the other question that comes up a lot of time, data sharing. Can these car companies share their data? And the way they gather their data, the sensors that they have, is so different that it's incredibly hard to distill that down to something that they can share with other vehicles and that makes sense. And also, currently, the car manufacturers are focused on having all the abilities on the car themselves. There's a lot of discussion of V2V and V2I, vehicle to vehicle, vehicle to infrastructure communications. You can go in parts of Boston, your GPS doesn't work because you're in a canyon. And if you're having a car that is reliant on communications and it goes down, you can't afford that. So everybody's currently focused on onboard and solving this problem within the car themselves. So I think we're a lot farther away from that model of where you share information between the cars, that you don't have to generate everything yourself.
Is there one more question, or we will move the panel to the future? Let's go with this one and then the one in the back.
Hi, so general question, which is, why don't we see a lot of aquabots? And there could be a lot of applications around aquabots, but we don't see a whole lot of them.
Aquabots.
Yeah.
Aquabots.
Yeah, so I think the biggest challenge with the ocean is just it takes so much to get out there, and it's such a harsh environment. And so it is very much still a hardware problem for revolutionizing that area. And I think, at least at Flight Infinity, we're trying to use what nature does already. Mother Nature solved this problem thousands of years ago. Why try to reinvent the wheel? Perhaps there's something out there that we can use now that is very implementable. And in the ocean, because it's so harsh, I think you need different kinds of sensors, so many new sensors, and these have been in the past very large and cumbersome, and so you needed large assets to move them around. But that's really revolutionizing, and so I think that is really changing. You look, there's so many aqua startups. I mean, there's two of us right here, you know, and that's really rapidly changing with this change in sensor technology, with this revolutionization in power technology to move them around and so forth.
So I would say that, you know, when I was in aerospace, I used to joke anything hard is rocket science. Now I say anything hard is like ocean science, because it's much more harder. Why? Because you can't talk underwater. No radio works. Internet doesn't work. You can't see. The pressure is enormous. So really, everything is pretty challenging. But there's biofoiling. Everything gets biofoiled, and you have to be clean, and motors break, and there is rust. So it's really worse than in space. No internet.
We're going to take one more question in the back.
And GPS.
Eric Roberson, Beast Capital. I grew up in the defense industry, developing military weapon systems for our nation's warfighters. And in that respect, it's always been interesting to me in terms of the moonshots we did in defense and the derivations of innovation that came along that pipe. For example, Star Wars in the 80s with Reagan, and we put satellites out there, had 7 years shelf lives, and ultimately it was purely supposed to be missile warning. Then we pushed into missile defense, space surveillance, and a lot of other things that we can't talk about. So with this ground-based mobility, robotics, autonomous, what derivations might fall off that tree as we move forward?
In military setting specifically,
no,
or
from a pure commercial perspective? As we push autonomous, we may not get there in the next 7 years. What else may?
So I think the question is about pushing autonomy, and actually brings in the question I wanted to ask you, Professor Kim, about, you know, you're talking a lot about biomimetics, but then we're also criticizing those models.
Yes, yes.
So, you know, there's trying to model it after a kid, it's trying to model it after an adult, it's trying to model it after specific, you know, industrial worker situations, and then you're going after animals. But, you know, I don't know, what are we missing here? Are there other mimetic, you know, models that we could and should use to get to the next, which is where I want to take the panel here, and to explore the future, and not necessarily just this grim Elon Musk scary future, but any kind of future where robotics can have a transformative impact?
Let me just briefly talk about the biomimetic part, because I was the one who pursuing for 15 years, and I'm still fascinated by how this machine works. But when it comes to building machine, because I've done multiple times, and then I realized there's so much discrepancies and inefficiency if you're trying to copy anything, and even the shape, even the very high level design aspect, we have to be very, very careful, and then you can. There's nothing is direct copying. Yet we are still fascinated and doing it because of the promotion actually aspect. Like if you design something, like you can recognize what it is and then try to sell to the, you know, the stockholders, and then what is that? And you have to explain a sentence instead of this is a cheetah robot. So you have to think about like human, as I said, like we are the intelligent being. We do way more than reflex, but we are also bound to reflex, right? That's why you look at the headlines and then judge about the articles, right? We have to deal with this animal side of human, reflexive side of human. So you have to think about the promoting part. You have to very carefully think about what reflex a human has to get actually things done. And the functionality part, we gotta be just like damn critical in every aspect. To really, is that really functionally useful to have a leg? Is the 4 leg is good, 3 legs good, and so on. Yeah.
So let's just briefly, perhaps, as we're moving to the future, one of the barriers, but also, you know, they can set some opportunities, is government regulation in this space is going to set some boundaries for what's going to be possible and not possible. Have any of you, as startups or as investors or as academics or in the industry, if you look at the regulatory environment for, let's call it the emerging robotic innovation infrastructure, what does that look like, Alex?
I would say what I see this technologies and development is moving faster than the regulatory framework around it. So we are working on that also with getting these systems as a prototype just certified and in operation is already a long and hard way, so that there needs to be a push created and a trust created that these systems are reliable, they are human safe, and but that will take time. And
but on the other side, I mean, these are massive industries, and there are governments involved, and there's disaster. I mean, there are a lot of use cases where the government can benefit in a massive way from this as well. So surely there must be a lot of excited people from DARPA and other places that are pushing for really to create a new innovation wave around this topic as well. I don't know if anyone else has interacted with. I mean, Grant, for instance, in your investment decisions, do you take into account whether this could possibly be shut down or turn into some sort of government standard by?
I would say generally investors avoid highly regulated environments like the plague.
So you consider robotics a non-regulated environment generally?
In our world, we're looking to signals from safety regulations and standards being pushed down around how we expand our current core base of robotics. So that's interesting, but the game I see with a lot of these companies is trying to outfox or influence the standards bodies to make sure that they're working their technology into how that standard is being written. And so I think it's on the margin like that, especially around some of these safety, human collaboration, interaction issues for scene awareness. But again, I look heavily to the automotive side to say that that's moving so fast, and every OEM has a huge innovation center in Palo Alto, a lot of them here as well. And there's just so much money going into that with heavy regulatory backend in Washington, where I also spent a decade. So I'm pretty sure that's going to be worked out, hopefully in the favor of some of the more innovative solutions. But again,
so I actually only have two questions, and just to broaden it, as Tom wants to bring it in. My second and last question is really about broadening the constraint level. So what are the constraints are there? We have talked throughout the day. Technology, obviously, you're limited by the good ideas, one, and two, by having some technologies that can show some promise. We have talked about other constraint factors. There's cost, obviously, involved. But what are the factors that you, as a panel, see as the most salient constraints on rapid mass adoption of robotic technology? And you get to start with that, Tom.
I will say regulation is a key issue, especially if you look at something like self-driving vehicles. So that technology is evolving incredibly quickly. And I think the technology to support having vehicles on the road, even if in limited applications, will far outpace our ability to regulate that appropriately. And we see that even so in the state of Massachusetts, Boston allows you to test self-driving vehicles on the road. But there are 10 bills being under consideration in the legislation right now to somehow regulate that. And they're all different, and whether they tax it or whether they limit it or whether they make sure there's no zombie cars, as they call them, vehicles without drivers. All of those are something that the companies have to be aware of and have to think about how do they move in that environment. And that's going to restrict some development because they'll either move to a state or an area where those rules are more lenient. So we have to be aware. I think the federal government is starting to step in at a different level now for the automotive. Traditionally, that's been a state-based regulatory body, except for certain instances. But I think the federal government is now starting to step in and encourage that. We want to see the encouragement of the development of this technology and the deployment and the public use of it. And so how do we do that while appropriately being aware of the safety risks? And that's true on whether they're collaborative robots around workers in a factory, whether they're self-driving vehicles, whether they're drones.
So I'm not going to have all of you answer, but if a couple of you want to jump in and talk about the constraints that you see in your work that are the most salient and the ones you're really working the hardest at, transversing. Is there a couple of you want to point that out?
Well, so I've been involved with DC and various discussions along this line, and I think the geopolitics of robotics is a really important area, and especially in international superpower too. I think a very important thing is that there has to be more transparent discussion between academic and scientific community as well as industry with the government, because the last thing you want is regulation based on opinions of politicians and not on technology. And on the other hand, you do not also want people like us who are making the technology be like super optimistic and not really take accountability of the risk. So, and I really think that, the way IoT is happening and what, Tom pointed out, the biggest concern I have is security here, and I think we are actually not prepared right now to handle that.
All right, so on that note, I'm going to just ask the panel one final question, and you only get a short answer. That's the end of the debate, but you each get to say something, and I'm going to ask you, what are you personally the most excited about in terms of robotics and the inflection points, or anything that is related to the core of what you do? Alex.
Most excited that I'm building a team, and it's fun to see how this team works and develops this and collects this robotic technologies. And I'm coming back to the child example, but we see how the child is growing and it can do more tasks in manufacturing, and it's getting older with us, with the team.
Great.
I'm going to commute with my robot from 2018. That's what I'm most excited about. Robot is going to be everywhere. It's going to help people.
That's very exciting. Maha from Flight Infinity.
I think I'm most excited about really taking inspiration from nature and finding ways of doing things that, as humans, we can't do. But if we can make a robot do it, we can explore whole new territories.
Sampriti from Hydroswarm.
I think that how do we use AI and robotics for economic and ecological benefit that can really massively impact the civilization.
Grant from ABB.
One is the industrial technology that's seeping into my life and positively affecting me, my friends, my family, and other ways, and just seeing it more democratized. And the second is exits. We need to see more value creation from this huge swarm of startups that have been propped up.
That sounds good. Sounds good. Tom?
So we get to see a number of different companies developing technology across a wide range. But one of the things that's, I think, really fascinating is how many are looking in the future and saying this will apply to what essentially is called elder care, or the ability to allow people to live longer within their home, be mobile, and just enjoy a better life longer. And I think it's going to be a fantastic use of this technology in the future.
And on that note, I'm going to facilitate one exit, which is a timely exit, because I think we are at the time's up. Please feel free to contact all of us here. I think there should be more coffee, and join me in giving a hand to all the panelists and all speakers. Thank you.